Hi guys, in this video we're going to be talking about functions. So the first thing we need to do is just talk about what functions are. So let's go ahead and take a look here. So here's our objectives. The first thing we're going to do is define a relation. So a relation is going to help us define a function. So define a relation versus what a function is. Determine whether equations represent functions. Use function notation. And then in our next section, we're going to evaluate a function and find the domain and range of a function. Okay. So here's what a relation is. A relation is a correspondence between two sets. So think ordered pairs. So when I pair two things together, it becomes a relation. Okay. So an ordered pair would be like an x value and a y value. They go together, so they are a relation. Now a function, so this is the definition of a function. Remember, you should be taking notes. Let's write this stuff down. A function is a relation, so it's a type of relation, where each element of the first set is called the input, and it corresponds to exactly one element in the second set called the output. So in other words, the x values don't repeat. You can't have one x value having two different outputs because each x value only has exactly one output. So when you're looking at a relation to determine if it's a function, if you see that no x values repeat, you will know it's a function, but it's okay for y values to repeat. Okay, so we'll look at some examples so you can see more what that's like. But again, it's okay if the it's okay if the y values repeat, but the x values should all be unique because each x value, each input, can only correspond to one output. So you can't have the same input going to two different outputs, but you can have two different inputs going to the same y value. That's still a function. When a relation becomes a function, so a relation might be y equals 3x plus 4. When we're using function notation on that, we're going to replace y with f of x. And all f of x is the name of the function. So this would be over here, f of x equals 3x plus 4. F is just the name of the function. And this in the parentheses right here is an x. That just means x is the input of my function. So on this side, we wouldn't evaluate anything. This is just the exact same thing as y. It's just written in a different notation. So it still just means y equals 3x plus 4. But this notation tells us we're going to take our function f and we're going to plug in some x values. Those x's are our inputs. And when we plug something into it, we're going to get out an output. Okay, so that's just notation. So now we're going to look at the following and we're going to determine, are they functions? So this first one, our x values are 1, 2, 3, and 4, and our y or f of x values, remember y and f of x are interchangeable, they equal the same thing. So when you plug an x value into your function and a y value comes out, we can call that y value y or we can call it f of x. This notation just means my x's are going to be replaced with whatever input is in the parentheses. Right now it just says f of x, and that's the standard for the notation. But if it said like f of 5, then I would be taking the 5 and replacing any x in the function with that 5 to determine what y equals or what f of x equals, which are the same thing. Okay, so again, we'll do examples, but since here my x values are all unique, 1, 2, 3, and 4, my x values do not repeat, so this is a function. Notice here that there are two y values that are the same, but that's okay, it's still a function because 2 only has one output. The only output 2 has is 4. 3 only has one output. The only output 3 has is 4. 4 has one output, it's 5, and 1 has one output, it's 2. So because of that, this is a function. So let's take another look. On this one, I have 1 that has an output of 5, but 1 also has an output of 7. Because 1 has two different outputs, 5 and 7, so the input 1 has two different outputs, this one is not a function. So let's see. So this one here is a function. This one is not a function. And it's because of the repeating x values right there. All right, so let's take a look at some graphs. So if you're looking at a graph, we're going to use something called the vertical line test for functions. So a graph is another way to represent a relation or a function. Remember, if you have x values and y values, you can plot them together on a graph. So this is just another representation. And in order to determine if a function is, if a relation is a function on a graph, we just use this vertical line test. So if every vertical line intersects the graph at only one point, the graph is a function. So in other words, if I could take and draw vertical lines, let me hurry and grab my pen here. Anywhere along here, okay, anywhere on the graph, if I can draw that line and it intersects more than one time, then this is not a function. Since each of these lines only intersect this function, the red line, one time, then yes, this is a function. But look at the second one. On the second one, if I draw a vertical line pretty much anywhere, sorry, those aren't very vertical lines. Vertical lines are straight up and down. If it intersects more than once, so these ones are all hitting it twice. And because of this one is not a function. So just kind of test it out. Draw some vertical lines, see if there's anything on here you could intersect more than once. This one right here looks like it might intersect more than one time. But since that's a closed circle and that's an open one, this point right here does not actually exist. It's just an endpoint for here. So that is actually still a function. Okay, now if those were both filled in circles and it intersects both of them when we do that, then it would not be a function. Okay, sometimes your graphs may not be connected like this and have lines. It may just be like a series of points on here. So as long as none of those points are lined up vertically, then this is a function. But as soon as a point gets, this 2 points have the same x value, like that, that would not be a function because that straight line would hit both points. So if you just see points on your graph, still check with the vertical line test. Just make sure that vertical line only touches one of the points in anywhere that you draw a vertical line. All right, so now let's go ahead and look at some examples here of different representations of functions. So far we've looked at graphs, we've looked at t-charts. Now we're going to look at some sets of ordered pairs. So this is similar to a t-chart, except for it's just written a little bit differently. This is written as these little sets of ordered pairs. So I know that the first one is my x values and the second one is my y values. So the x values are 2, 3, 1, and 9. The y values are -3, -3, 4, and 2. So again, just like when I was using the t-chart, on the first on the first section of functions that we looked at, or relations that we looked at to see if they were functions, I want to check the x values and make sure they don't repeat. So on this first one, I have x equals 2, x equals 3, x equals 1, and x equals 9. So each x value is different. And because of that, I know this is going to be a function because each x value is unique. So the same input is not going to two different outputs. Okay, so this one right here is a function. Okay, the second set here, we have 1, -1, -1, 5, 1, -6, and -3, 2. If I look at the x values, 1, -1, 1, okay, so this one and this one match. And because of that, I automatically know that this is not a function because the input 1 has two separate outputs. It has both -1 and -6, so that is not a function. My third one here, 1, 4, 9, and 3, those are all different, they're all unique. So even though I have two y values that are the same, this is still a function because 1 only has one output, it's -1. 4 only has one output, it's 8. 9 only has one output, it's -1. And 3 only has one output, it's 2. So see the difference? Like here, this is a function. Well, that's a pretty bad looking yes. This is a function because all the x values only go to one y value. But on this one here, 1 has two different outputs. 1 goes to -1 and 1 also goes to -6. So it's still a relation, but it's not a function. Okay. So the last representation of functions that we're going to look at here is, these are called mappings. So the mappings have what's called the domain or the input. So these all three look a little bit different. So this one's telling me the x's are the starting point and they're going to, excuse me, I accidentally clicked it. The x values are the inputs and they are going to y values, and those are the outputs. Here it's just calling these ones inputs, so these would be the x values, and they're going to the outputs. And here we have the domain, which is another name for inputs, and they're going to the range, which is the output. You can see the arrow is going that direction. So we know that these are our x's and these are our y's. So on a mapping, we do the exact same thing. We're going to see if any of these x values are headed towards the same, or to two different y values, sorry. So -1 only goes to 5, 0 only goes to 3, 1 only goes to 5, 2 only goes to 11, and 3 only goes to 21. And because each of my inputs only goes to one output, this is a function. So on this one, I can say, yes, this is a function. Whoops. Okay, on the second one here, notice here that 2 goes to two different outputs. 2 has an output of 20, but it also has an output of 40. Because of that, this is not a function. Okay, so again, the x values cannot repeat. In other words, I can't have one x value going to two outputs, but it's okay for y to repeat. If -1 and 1 both go to 5, that's okay. This is still a function. Okay, on my third one here, I have 1 goes to 2, 0 goes to 2, 1 goes to -3, 2 goes to -2, and 8 goes to 3. Again, 2 inputs go to the same output, but that's okay as long as each input only goes to one output. So -1's only output is 2, 0's only output is 2, so yes, this is a function. So your assignment for today should be a really quick one. You're just going to look at some of these representations of functions and you're going to determine yes, they're a function or no, they're not, and then just write that next to it. And then just go ahead and submit it through Canvas. Probably through Canvas is better because then I will be able to see it from home. So have a great day, guys, and we'll see you next time.